Start of this, I'm a scientist. The other three are HR people. This is a HR talk. I don't know much about HR. Okay, so I'm going to set the context for about this paper. Why do we do it? How do we do it? And give you a comparison of two teams involved in an eResearch project that we did last year in GA, a scientific team based in GA, and a technical team based in Perth at CSIRO Minerals Down Under, led by Robert Woodcock and Ryan Fraser. There's some education and training implications from this piece of work, and then I want to give you the key learnings. So last year, GA decided to run an eResearch pilot project. It was to assess if there was any business benefit to GA in applying advanced ICT technologies to enhance scientific outcomes. We actually did it through 3 partnership agreements. The first and the most major one was with Robert Woodcock and CSIRO to see if we could set up an eResearch infrastructure. The second was with Ben Evans to trial HPC. And the third was a smaller project with ANZ to expose the GA catalogue as a web service from a single GA network instance that could service both the CSW and OAI PMH harvesters. Our project within this 12 months built an internal data access portal based on the AuScope portal, and there were 3 internal projects that participated. The first, as we've mentioned, is the Virtual Geophysics Laboratory, which enabled data to be accessed as either WFS, WCS, and also connect to both HPC and cloud. The second was a Landsat satellite delivery project as web coverage services, and the third was a catalogue metadata discovery through to the ANZ portal. So just to give you some background, the Geophysics portal project was only running about 4 months when it was awarded a Nectar Early Adopter one of the virtual laboratories programs. The satellite delivery, we hope within a few months, will be accessible as a web coverage service. That is the last 10 years of Landsat data, either through the new GA portal, or we're hoping to work with ANZ and GEOS. And as it's a web service, anyone who has a portal that would like to connect to it, come and see me afterwards. The ANZ project was also extremely successful, and now it's causing a lot of upset in my organisation because people are now realising that if you type in some of our products, you will actually go to the ANZ site, not the GA site. That is how well they have optimised metadata and syndicated to search engines, and it's a credit to them. So the real important point I want to get across is that we weren't mucking around. The people involved in these projects had serious infrastructure and the building of it entirely in their aims. So from those projects, we were able to produce a business case for our executive board by October of last year. We said, yes, this is what we want to do. We want you to go forward and provide a roadmap. So Rob and I spent the last 2 months frantically writing this roadmap. And it covered 4 topics: high-performance computing, high-performance data, an integrative infrastructure for both, and also a section on human resources. That was what the contract said. Oh dear. I'm a granite petrologist, Rob's a software engineer, so guess which part of the project was the most underdone? The HR bit, right? And what we were supposed to do in the contract was do an audit and conduct a gap analysis. But if you're logical, this is a bit difficult to do because you really had to finish the project before you knew who was needed. The elephant eviscerator problem soon emerged, which I'll come on to next. And without doubt, it was the most difficult, and we admitted it was the weakest part of our roadmap. Enter HR. I thought it was amazing that our general manager, who runs our HR section, read the report and called me up to his office, and I thought, oh, here we go, bad report. But he said, I think that what you are indicating in the eResearch work that you want to do, there is actually a significant skills change. And I said, I agree with you, but we couldn't quantify it. And he wanted input to the GA workforce plan, which has just come out, based on these capability gaps we'd identified but could not quantify. And so the key questions for the new strategy were, do other projects, we were so successful with the satellite and geophysics groups, do other projects in GA have these skills? Do we need to change some of our learning and development? But the thing he was particularly interested in was, who do we really need to target in our graduate recruitment program? So I want to set the scene, because this is a point I've been working with, as you said, for 10 years in eResearch, and sometimes I actually despair, because have we actually really produced all that much? And I think that I'd like to set the scene that this is one of our great changes. And it's an old fart, I can say that, because I actually in 1977 introduced the electric typewriter into our organisation. I watched the typing pool disappear, and I also had watched the drawing office change from manual cartography into digital. And we are going through another one of those great changes. But I think because it's digital to digital, we are not picking it up. And to me, the message from this change in time is that our tall ships failed because they could not get any bigger. Tall ships were limited by the size of the mast, which in turn was determined by the largest trees you could find on the planet, and they only grow so big. So that's why we had to invent a new thing, which was steam. And we cannot handle the oceans of data because these were very manual driven, manually created, manually run, whereas steamships start to have standardisations of engines and tools and kits. We have to recognise that we can no longer handcraft our way of accessing multiple data sets. But I look back and see what's going on in some organisations, and what we're effectively doing is asking carpenters to become mechanics. This is something I watched in those changes I talked about. Well, I can't use the typing pool because once you introduce the electric typewriter, they all went down with RSI. So that's kind of why scientists started typing, and then they got RSI. But if you look at the drawing office, and I remember that change extremely well, looking at all these people that could do these beautiful maps, but picking who would go into digital cartography was very difficult. And that was the problem Rob and I had, which is why we jokingly called it the elephant eviscerator problem, because you knew what staff member you wanted, and like you could say, I want an elephant eviscerator, and 1,000 had come out of the woodwork. And the problem was because it was so new and you wanted to trial, they could say they've got the skills, but until you actually got them doing it, it didn't work. Okay? And so what we then said was, well, let's look at the team that actually made this transition to eResearch in GA, or the two teams, and see if we can identify what their characters were. So this is not a scientifically valid study. I must emphasise this. And as a scientist, classically trained in the old days 40 years ago, it's not science, right? This is not a biased sample, a very, what do you say, substantive sample. It's not a statistically viable sample, but the results from the two teams were internally consistent. And the team leader profiles will not be discussed further. And I'll show you why. The opinions were not included in the results because otherwise they biased that pretty small sample. So, in comes HR with these two specialists in capability profiling. And they designed a template to generate and document the data we gathered from the two teams. Firstly, each participant was asked to define what is eResearch, because if we had a common understanding that both groups could quantify what eResearch was, then we had the starting base to put the actual questions that were going to come out in part 2, which related to their qualifications, their job experience, their skills and knowledge, behavioural attributes, and the organisational support they felt was necessary for us as an organisation to move forward with a solid eResearch program. So, 1, what is this eResearch stuff? And both groups pretty well came with the same answers and the same things. As I said, we had one team in GA where we ran a couple of workshops, and the other team in Perth we had to do by email and documents. It was the only way. I didn't have the budget to go over to Perth to work with them, but a box of Tim Tams helped get the results I wanted. So, eResearch was defined by both groups as being connected to electronic data and enabling scientists to work directly on the observational data rather than synthesis of subsample data. This is really important. It enables probabilistic analysis with multiple scenarios being run and uncertainties being quantified. It is characterised by technical innovation and undertaken by those willing to work at the bleeding edge. That was a very common characteristic. And I thought this was beautiful. eResearch requires computers to enable it and humans to drive it. Okay, so now starting to run through the groups, and I'll show these, the GA team and then the technical team. And in a few of these slides, there'll be 2 red dot points. And they were the ones that these HR experts came to me and said, wow, this is something that's different and not what we expected. So the GA team had BSc to PhD. It was very strong with mathematics, whether I was dealing with the geophysicists or the satellite people. And they had some computational science, modelling and numerical analysis in their training. This was a thing that our HR group found very surprising, the high level of PhDs within this technical team. They had computer science, programming, maths, geophysics, so they actually had science in their degrees as well. They had science qualifications, but a much stronger focus on computer science and engineering than what the GA science teams had. So how I kind of drew it was, well, they weren't pure scientists, they weren't purely down here, but the CSIRO team was closer to that end and the GA team was closer to that end. Experience. So we asked them what experience in job training had you had that you felt enabled you to do this eResearch project better. And so these are the ones that they nominated with logical thinking, etc., data analysis, programming skills. But what the scientists felt, and I think it was an interesting point, was that they all had this capability to think laterally and to think big. Okay? Now, when we went to the CSIRO team, this was kind of interesting because they actually said why they were able to work with the geophysics laboratory was one of them actually had a PhD in geophysics. So even though he was working as a software engineer, he had that strong scientific understanding. The other important thing, about this team was that you have to give it to them that technical team has extensive experience in building eResearch tools. These are the team that developed the SysStack, and there's now 27 instances of that around Australia and the world. So they came in and hit the ground running. And I think one of the problems we had with the project was because they produced the results within 3 months. Everyone said, oh, it has to be a hack. But not everyone, sorry. I must say a lot of people appreciated what these guys did. But the important thing is, what is the value? The high skills, PhD qualifications, or was it this experience? I don't know, and I don't have a big enough sample to determine. The behavioural attributes were here, science, willingness to try new things. Well, crying out loud, if you're doing eResearch, you've got to be trying something new. You're a risk taker, you're an early adopter. In the technical teams, this was the same. So they're all kind of going for the same skills. But this is remarkable point number 2 from HR, was at the top of every list of the CSIRO people was the ability to communicate and actively listen. And when you think about it, these guys were the support team for this. And so this learning and listening and communications was seen as very valuable. Organisational support. We want an organisation that's going to be flexible to introduce this. CSIRO actually has a way of fostering early adopters. We needed a specific eResearch team, and so we weren't talking about existing staff. What we wanted people who understand MPI, who understand CUDA, who know how modelling, who understand how uncertainty analysis works, to support these guys as they scale up to work on the bigger machines. We want to recognise that the skills level of the software developers is quite high. That's something that's often very hard to get across. And the recognition of the hybrids. This was well expressed by the CSIRO team, who actually said, our team is built on ex-scientists or reformed software engineers, now scientists, who try to bridge that gap each day. And this hybrid is something that I think is fairly important. So I just want to explore that. And we had these results internally, but it wasn't a very big team, okay? So let's look and see with a report that's external and look at the Science 2020 report, which I don't know whether any of you have looked at, but it's really worth reading. And in the summary, you can't read it, but here, blowing up the last point. Our findings have significant implications for the education of tomorrow's scientists and science policy funding. Scientists will need to be completely computationally and mathematically literate by 2020. It will not be possible to do it without such literacy. And the second point is that this has implications for education policy right now, which was a point Andy Pittman made earlier. So I want to do a trip down memory lane. So here's the report. And this is what the Science 2020 is saying. But last century, when I was doing my early work, the scientists did it. We didn't have a special IT or IM team. You did the whole kit and caboodle. And then in the 1990s, we started to bring towards people who could actually do a bit of IM. We started to bring the professionals in. And by the early part of this century, I argued there was quite a divide between the two. You're either IM or you're science. And for someone who's a hybrid like me, you don't fit into either area. And so I think now we have to rethink what I am going to now call the X factor. And I take the X factor from that seminal paper by Jim Gray on the the fourth paradigm. And what he says is we need to think about the two teams. And you really, in the hybrids, you have the geoinformatics, hydroinformatics, bioinformatics, and in the computational areas, you have the computational scientists. These are the people that we really had in those two teams in GA and CSIRO. They were sitting in the middle. And that's the thing we need to enhance and work on. So what we actually said was, for education needs, we need academic courses in data science, science management, data curation, computational X and X informatics. In Australia, at best, these courses exist in the postgraduate level. We need these at undergraduate level urgently. And from some of the work I've done with colleagues in the US, courses in data science at some universities are now compulsory at undergraduate level. This is what we're saying about influencing the training of the future if we are to expand eResearch. So, the key learnings is that the profiling of both teams provided evidence-based information and understanding of the skills and qualifications and characteristics required for these eResearch projects we ran in GA. These understandings were used to inform recruitment, learning and development strategic decisions, and in fact they were used by our chief scientist as part of his recruitment strategies for our graduate program for 2013. eResearch requires a culture of these multidisciplinary teams with both scientists, computer science, information management specialists all working collaboratively together. And the eResearch workforce of the future requires a scientific workforce that has a greater capacity in mathematics, numerical modelling, statistics, computational skills, and software engineering. But they also have to have the capacity to think the bigger picture and integrate across multiple domains. Because one of the problems we currently have is with the investment in petascale computers and the cloud, we are awash with CPUs. And it's the people who can think big and think those big problems, which are the ones that characterised, as I said, the GA teams that were working on this project, are the ones that I think we need to foster and encourage. Thank you.
We have time for a couple of questions, perhaps some will turn their opinions. It is kind of a big room without very efficient, so I'm going to just ask you to come to the mic.
In modelling in 2009, in a paper which I don't think has been referenced anywhere, and I should know because I gave it, I talked about exactly what you're saying here. I've come out of a hydrological modelling background and helped some geoscientists do some seismic processing. And I think the thing that you've missed in that, which captures it perfectly, the last slide of my talk was there is a place for people coming out of the sciences with a computational background. The difficulty you're going to find, I think, and I now work in a computer science department with John, is people who are being trained as computer scientists will probably find it harder to move back and interact with people than people coming out of the domain sciences who have the HPC
Yeah.
parallel programming expertise. That's my comment.
Yeah, no, it's, well, as I say, I'm worried about this paper because it doesn't have a statistical foundation for it. But when we actually looked at the guys, because about 20 people that were interviewed all up, you could actually see them at their career point. So like the guy who'd done PhD in physics, he just flipped over into the science. And it's just amazing that it was just a very, very fine line between the two teams. Yeah. I mean, the issue boils down to, do you teach the computer scientists geoscience, or do you teach the geoscientists computer science? And that's the battle.
You have another question? I might actually just comment that 3 years ago, before we changed our Bachelor of Science to ensure that no majors require more than half a degree, to encourage people to actually do 2 majors. The intention, at least on my part, was a lot of those people were combining computer science with science major. Although it's working. Okay, if there aren't any other questions, you've got a couple of minutes if you want to switch rooms.